Hello everyone, this is Ashwini Abare and today we will discuss how to convert this assignment using pointer. In last video we have implemented all the operation on matrix. Now we will convert this assignment into using pointer. Now what is the meaning of pointer? Pointer is one type of variable which stores the address of another variable. So right now, suppose if I will consider my function as a accept, I want to declare a pointer whose name is x. So if I will declare x as a pointer, so x becomes now pointer. X is a pointer which will point to your matrix A. X is a pointer which will point to matrix A. So if you want to do this, so here before in calling function you have to pass the address of A. So we cannot pass the address of A simply, so we have to give the starting address of A. So starting address of A is address of A of 00th element. Okay, so here we have passed the address of the A, and here x is a pointer which holds the address of A. So finally how it will accept the element, at where it will store at address of x of I and j. So first we will give the declaration. Instead of this accept, now we have to give the declaration here. Save, execute, compile and run. Okay, now x is already holding the address, so no need to again specifically mention the address. One more thing, x is a now pointer, so no, we cannot pass I and j. Okay, wait. X is holding the address of A. Now we have to store all elements on a particular address. So how you will calculate the address of each and every element? So for that purpose, if I will consider one file, suppose yes. Now if I will consider A matrix contains 2 by 3 elements, so number of rows are 2 and number of columns are 3 and elements are 1 2 3 and 5 6 7, suppose 8. These are the elements which are actually present in A. But how these elements allocate or reserve the memory? In program, if you will see, in program we have allocated the dimensions for your matrix A is 10 by 10. So maximum it can store how many elements? 10 elements in one row and 10 columns. So suppose assume that we are having the starting address of A is suppose 0. So on 0 it will store the element 1, then next location is 1, on 1 it will store the 3, then suppose next location is 2, it will store the 4. In this way 3, 4, 5, 6, 7, 8, 9. Then it will store next element, suppose 10, 11, 12, or simply if I will say that this again it will repeat for next row, again for next row. In this way it will repeat this total 10 times. Means in every row maximum how many columns are present? 10 columns. So every element will be starting at 0th position. Then suppose, so here 1 will be stored at 0th position, 3 will be stored at 1st position and this element 4 will be stored at 2nd position. But this 5 will be stored at next row, meaning next 0th position, then 6 will be stored at this position, 8 will be stored at this position. simply it is present at 10th, 11th, 12th, 13, 14, 15, 16. So every row is start after 10 elements. Why 10 elements? Because our dimension is 10 by 10. So here if you want to accept the element, so how you will accept? In accept function, x give the starting address plus we have to give the displacement. How we can give the displacement? Every row is after how many elements? 10 plus g. So how you will calculate the address of each and every element? Row value should be multiplied with maximum number of rows. So x plus, so initially I is 0, j is 0, so I into 0, 0 plus 0, so finally you will get the starting address. So automatically your first element will be stored at 0th position. Next, j plus plus, but I is 0 only, so I 0 into 0, 0 into 10 you will get 0 plus j is now 1, so x plus 1, so it will store at next location. Again, I suppose first row is incremented or first row is finished. Now I increment, so I becomes 1, so 1 into 10 and first element suppose 0, so 10 plus 0, 0, so x plus 10, so starting address plus 10 you will get the next location. Okay, so in this way. Now one more thing, here we have write x plus 1. It is not indicate that your pointer will increment by 1. It is totally depend on which data type you have used. If you will use character, so pointer will increment by 1 byte. If it is an integer, then it will increment by 2 byte. So first of all I will close this. No, save, execute, compile and run. Okay, first number of rows is 1, 2, 3, 4. So matrix is accepted properly. 6. Incompatible pointer type expected int star, but argument is of int star 10. A. Line number 13. Okay, now we will change the display function. Again, in display function, x will store the address of which matrix we have to display. So here x. Now here we have to display the element. So whenever you want to fetch the value, there is one operator which we can say as a star. X will give the starting address, I will be I into 10 plus j. So we have declared A matrix is of 10 by 10. So every matrix is 10 by 10. So we will use this. So star means value which is present this address. So address is which one? X plus I plus 10. So again compile and okay, wait. In display function, so after accepting we have to give the address of A of 0. Same changes we have to made for B matrix. So address of B of 0, display address of B of 0, and display, change the declaration of display function instead of click on compile and execute. So first accept first matrix 2 by 3, 1 2 3 4 5 6, matrix is done. Second 1 by suppose 4, 1 2 3 4, it is displaying properly. Now we will take the next operation. Suppose first two are over with pointer. Now we will take the addition. So addition also we have to pass the address of first matrix. Suppose A of 0, then address of second matrix 0, then address of third matrix, which will be your result, where we have to store the result. For display also, here we have to pass address of now in addition we have to declare a pointer. So star x will point to your A matrix, then y will point to your B matrix, and z will point to your C matrix. So here we have to store the value at which location? Address z plus I into 10 plus j. What we have to do? Value which is present at which address? X of x plus I into 10 plus j. We have to take the value from that address and we have to add with the value which is present at y. So y plus I into 10 plus g. Addition done. Again same, compile and run. First addition, suppose 2 by 2, second matrix is also 2 by 2, addition third, addition is upper 6. Now we will convert transpose matrix and multiplication simultaneously and we will run this. Address of A, address of, so not a star, star indicates value. Now we have to pass here address. For address operator, address C of 0, display address of C of 0, multiplication, pass the address A of 0, address of C of 0. For display, address of C of 0. Now change the transpose function. Here we require x as a pointer, so remove the dimension. X is now pointer which is pointing to your matrix whose transpose we have to calculate. So here we require the, what we have to change? Value at, not this bracket, value at which address? Z. So Z plus I into 10 plus j, which will be equal to value which is present at x plus j into 10 plus I. Transpose, give the declaration first. Now we will convert multiplication also. Again, x is a pointer, y is a pointer, z is a pointer. Value at this address should be equal to 0. So z plus I into 10 plus k is equal to 0. Same way, value at which address? Z plus I into 10 plus k, bracket close, value at z. Okay, one more thing. Here we can write simply as, instead of this we can write as a plus equal to, meaning is same. Z of ik plus equal to x of ij into y of jk is equivalent to z of ik equal to z of ik plus x of ij plus y of jk. So simply we can write this, value of x plus I into 10 plus j into, which is multiplied with value which is present at y plus j into 10 plus k. This should be multiplication. First give the declaration of multiplication. Save, execute, compile and run. Addition of matrix I have changed. Okay, wait, delete this. We are having addition of matrix, this one. Okay, it was correct, we haven't put semicolon. Okay, save, compile and run. Now first 2 by 3 6. Then first we will take the transpose. Transpose is correct. Now for multiplication we require one more matrix. So suppose 3 by 2, 4 5 6 7 8 0. Multiplication, fifth one, multiplication. So 4 6 8. Oh, it is correct. Okay. In this way we have finished our matrix assignment with and without pointer. Okay, thank you all of you. Thank you for watching my video. Please subscribe this video. Thank you.